Hello everyone, welcome to my YouTube channel. This is my first video on my YouTube channel. By profession I am a teacher. My main objective is to just produce informative content and continue to improve on each video, right? After teaching students out for many years, I have decided that I want to reach a broader audience, or you can say as a broader learners, where I can share my knowledge with all of you. So today this video is for the term 2 class 9th chemistry, where the chapter is atoms and molecules. Before starting up with the chapter, I would like to just share the term 2 syllabus, because there is a reduced rationalized syllabus which we are going to discuss in this chapter. So let's have a look on the rationalized syllabus once. Yeah. So here you can see that there are two chapters for this term. One is your atoms and molecules, and other is structure of atom. In atom of molecules, some of the contents have been reduced. So basically we are going to study all about the atoms and the molecules, and more important, the mole concept. Okay, so let us start. Yeah. So just a minute. Yeah. You might have heard of Democritus, this great scientist, a Greek philosopher. Okay, he was a Greek philosopher who has given he was the first person who has shared his idea about the atom. Later on you will find that the different scientists have given their opinion for the discovery of the atom. Okay, like Dalton was there, Rutherford was there, Bohr was there, but Democritus was the first scientist who has said he has shared his opinion about an atom. He has quoted a very well thing here. You can see that nothing exists except atoms and empty space. Everything else is opinion. Such a good thought it is about, right? About the atom. So considering what exactly is an atom, there are different names by which an atom is called, like anu, there is like parmanu. These are the other synonyms which have been used to first define the atom rather than using this technical term. So these two terms were basically they were put by the scientists like Maharshi Kanad. Okay, where they have said an atom to be as anu or parmanu. Later on it was considered, after the Democritus, he has proposed that matter is made up of this extremely small particles which are atoms, and the term atom itself, it means indivisible. This was the statement which was proposed by the scientist Democritus. Later on the theory came of the Dalton's atomic theory. You might have heard of Dalton's atomic theory, where he has proposed certain postulates related to the atom and its structure and its inner component. We are not looking into this Dalton's atomic theory because, as I said you, we will be discussing the rationalized syllabus, and this is a revision, like a short video for revising this chapter content for your term 2 examination. Fine. So Dalton's atomic theory we are not getting into. You just need to remember about an atom is, earlier the atom was considered to be indivisible, but later the subatomic particles within an atom were discovered. ठीक है, जैसे कि suppose you can see here, like this is in the center, you have the nucleus, ठीक है, and in the nucleus you have the protons and neutrons, right? Protons and neutrons, proton is a positively charged species, जबकि neutron जो है एक neutral species है. No charge is there on the neutron, right? And around the nucleus you have the presence of electrons which revolve around the nucleus, right? Now with this, after the discovery of an atom and the postulates given by that, later on there were certain queries related to that. How do these atoms they participate in a chemical reaction? What play does the atoms, what role is being played by an atom in a chemical reaction? So to overcome those queries, laws of chemical combination was proposed. laws of chemical combination was proposed, which is a combination of two laws. First is the law of conservation of mass and second is the law of constant proportion. Law of constant proportion, it is also known as law of indefinite, okay, law of indefinite proportion also it is mentioned. So this first law, which is their law of conservation of mass, it is nothing but it is similar to what is law of conservation of energy. Okay, क्या देखते हैं कि जब भी whenever a chemical reaction or a change is taking place, your total mass of the products is equal to the total mass of the reactants. Like we study in law of conservation of energy, where we state that energy is neither created nor destroyed, it is just transformed from one form to the another, right? Similarly, जब आप law of conservation of mass की बात करते हो, so let us take an example. Suppose carbon plus oxygen gives you carbon dioxide, right? As per the law of conservation of mass, what does it states? That the total mass of the product, if you calculate the mass of this product, carbon is 12 plus 2 into oxygen's mass, which is 12 plus 2 into 16. So it becomes your 12 plus 32, which is 44 grams, right? So this is the mass of the product. What it is telling, that this mass of the product will be equal to the sum of the total mass of the reactants. That here again, if you will see, this is 12 grams and plus oxygen का अगर आप देखोगे तो again 2 into mass of oxygen atom, that will become your 32 grams. So if you sum this 12 and 32, so again it will be 44 grams. ये बात आप लोग को समझ में आ रही है कि लॉ ऑफ कंजर्वेशन ऑफ मास यही बोलता है कि द राइट हैंड साइड the product's mass is equal to the reactant's mass. That is what called as a law of conservation of mass. Second law, that is law of constant proportion. This law of constant proportion, it is also, as I said you, it is also referred to be as a law of definite proportions. Okay, it is also referred to be as law of definite proportions. Now technically if you will see the definition of it, so here it is mentioned that कोई भी chemical substance में elements, they are always present in a definite proportion by mass. Let us again take an example of water. So in this water क्या देखते हैं आप, there are two hydrogen atoms are present and one oxygen atom, right? Two hydrogen atoms and one oxygen atom. So if you will see by ratio, the ratio is 2:1. Mass ratio, if you will see, so it will be 2:, oxygen mass of single oxygen atom, it is 16, right? So if you simplify this, you will get it as 1:8. So by mass ratio is 1:8. Now whether you take this sample of water from any part of the country, whether India, Raipur, anywhere, so this ratio is always fixed. It's not like that the water which will collect from Antarctica sample, there you will get some different ratio of this hydrogen and oxygen. There also the ratio will be always 1:8. This is definite, constant. This is referred to be as a constant. It will always remain the same. 1:8 ही रहेगा, वो आपका चेंज नहीं होगा. That's what this law of constant proportion it states. Yes, is it clear? So this basically means that whenever a compound is obtained, so ये जो atoms combine होते हैं, the atoms which combine, okay, their mass ratio is always fixed. ये आपका हमेशा क्या होता है, fixed होता है. It is always fixed. That is the law of constant proportion, right? Fine. So let us have a look. Just now we discussed about this part. We discussed about the atoms, right? Then we discussed about the law of constant proportion. Molecules, atomic mass and molecular masses will be discussing in the upcoming slides. Okay, yes, sorry. Okay, fine. So before considering the atomic mass, I would like to discuss about the atom and molecule, the difference between the atom and molecule. Yes, let us see here. When we say an atom, so atom we know that it is the simplest unit, or you can say as the smallest unit of matter. Yes, like when we talk about our body, so in our body the basic unit by which it is made up of is cells. Similarly, for a matter, the simplest or the smallest unit which it is made up of is atom. Like example, hydrogen atom, carbon atom, oxygen atom, then you can say nitrogen atom. These are all what? These are the atoms. These atoms, they combine to form the molecule. Like just now we have seen the example of water molecule, है ना, CO2 molecule. So in this what is happening? One oxygen atom, it is combining with two hydrogen atoms. Yes, one oxygen atom, it is combining with the two hydrogen atoms. Similarly here, one carbon atom, it is combining with the two oxygen atoms. Yes or no? So molecules are what? Formed by the combination of atoms. And how do they combine? That we have just already read in the two laws, that is law of constant proportion and law of chemical combination. Under the law of chemical combination, law of conservation of mass, that whenever a compound is formed, so the mass of the products and the reactants both are equal. Product side and the reactant side both are equal. And similarly, if any compound is found, whether it is H2O, whether it is CO2, whether it is NO2 or any other compound, their mass ratio is always fixed. Okay, their mass ratio is always fixed. Now talking, this is about the atoms and the molecule. Let us discuss about the next thing, that is your atomic mass. When we talk about atomic mass, okay, just a minute, sorry. Yeah, when we talk about atomic mass, there is some glitch coming, just a minute children. Yeah, yes, so atomic mass in simple terms, what you will understand? Mass of an atom. Yes, if I'll say atomic mass, so what it will be? Mass of an atom, right? Technically, if we'll see into the more detail of it, that what exactly this is atomic mass refers to. So like in earlier days, long back ago, when there were no equipments, there were no techniques to measure the atom. At that time the science was not that much advanced, but still the scientists have done so much effort to find out these all things. So there was no such thing. Earlier they took hydrogen as a standard unit, where they'll keep on one side hydrogen and on the other side the atoms, and with relevance to that they'll measure the any particular atom, any XYZ. So the number of hydrogen atoms which are kept, like suppose if this particular X element, after keeping 4 hydrogen atoms, it is equal to the mass of that, so it becomes like that, the mass of X atom, it is equal to the 4 hydrogen atoms, mass of 4 hydrogen atoms. But later on, this hydrogen to be taken as a standard unit was discarded. Why? Because hydrogen, it was by using the hydrogen for higher elements, we cannot use this hydrogen atom को we for higher elements जो थे, it was not applicable, we cannot use. So later on this was discarded, and then we took carbon as a standardized unit. Yeah, just a minute. So here we took carbon carbon element as a standard unit. Then we took carbon C12 isotope. Okay, carbon, it has a two forms, one is your C12 and another one is your C14. So we took C12 as an isotope, C12 form of the carbon as a standard unit, and we tried to measure the any element's mass. So when it was seen that the relative mass of any atom, it is compared with the mass of atom of C12 isotope taken as a 12 units. Means if any element X is there, you need to find out the mass of that X element. So on the other side, you need to take carbon C12 atom as a standard unit. Suppose for example, like let us take this example of oxygen. Here we are writing that oxygen mass is 16 U. That means with respect to this C12 atom, it is 16 times heavier with respect to this C12 atom. Here I have written also that 1 AMU, it is equal to what? It is equal to 1/12 the mass of C12 isotope. So it is 1/12 the mass of 16 times. If I take oxygen here, अगर हम यहाँ पे सोडियम लेंगे, so it is 23, so it is 1/12 the mass of 23 times heavier than this 1/12 mass of the C12 isotope. So that is how we define the atomic mass. And you can see here the unit is U. U is referred to be as like a unified mass. U is referred to be like as a unified mass. Is it clear? So atomic mass is simply a relative mass. Why we are saying it is a relative mass? When we measure our weight, so we don't say it is a relative weight, right? Suppose my weight, suppose for example if I am 60 kg, so I am not saying that it is a relative, it is the absolute value. But in case of this atomic mass, we consider relative because we are comparing it with carbon. Now we are giving this atomic mass with respect to the carbon. That's why it is always a relative mass with respect to what? C12 isotope. Now here I have placed some elements whose symbols are there. It is very important to learn this right from this basic level, class 9. क्या होता है कि जब when you go to the higher classes at that time, you don't read all this stuff, so it becomes very painful to remember at that time. So you should learn this, all the elements with their atomic masses. For class 9th level, I would suggest at least 1 to 30 elements from the periodic table should be memorized. Fine. So this was about the atomic mass. Now consider the molecular mass. As I said, like in simple terms, when you say atomic mass, so what does that mean? Mass of an atom. Mass of an atom. When I say molecular mass, so it will be the mass of a molecule. When I say molecular mass, so it will be the mass of molecule. Now here also it is the relative mass. Relative mass means again we are comparing it with respect to something. And what is our standard unit? Our standard unit is again the C12 isotope, right? But here when we calculate the molecular mass, suppose for example I will take glucose. Glucose is what? C6H12O6. Suppose I said find out the molecular mass of this compound. So how the molecular mass is calculated? By adding the atomic masses. So like mass of carbon plus mass of hydrogen plus mass of oxygen. Now here you can see that with carbon there are 6 carbon atoms, so you will multiply 6 into mass of single carbon atom. Here 12 hydrogen atoms are there, so here you will multiply 12 into hydrogen, and here 6, so here 6 into mass of oxygen. Now here you can see, yeah, so 6 into mass of one carbon atom is 12 plus 12 into mass of one hydrogen atom is 1 plus 6 into your mass of oxygen atom is 16. Yes, so here you can just calculate the masses with respect to this. Let us take a small example of like water molecule, where you can see that 2 into mass of hydrogen plus oxygen. So here it will become 2 into 1 plus your 16, and it will become 2 plus 16, it will give you 80. Yes, can you see that? Okay, let us take some few more examples. Suppose if I'll say find the mass of NO2, nitrogen dioxide. So mass of nitrogen plus 2 into mass of oxygen atom. So mass of nitrogen single atom is 40 and plus 2 into this is 16, then 14 plus 32, it will become 6 and 46. Okay, so for this you need to learn the periodic table. It is very important to learn the periodic table, elements from atomic number 1 to 30, their symbol, their atomic number and mass number. This is very important to be learned, otherwise you won't there are some kids जिनको पता ही नहीं होगा कि नाइट्रोजन का मास यहाँ पे 14 कहाँ से आया, हम ये 16 क्यों लिख रहे हैं. So this is all from that table. Yes, like this sort of table which I shared. So atomic mass table, you will get it in your NCERT's book. Fine. Now the most important topic of this chapter, very important topic of this chapter, where most of the students they get confused, and till class 12th also they face this problem. Very important, that is mole concept. What is this mole? We symbolize this mole with small n. कैसे इसको symbolize करते हैं? We symbolize it with small n. If you see mole, simply to understand, like just basic information, whenever we say 1 mole, it is equals to 6.022 into 10 to the power 23. Okay, now where exactly is it used? Suppose when we go to the market for purchasing any vegetables, so we say give me that 1 kg of tomatoes or potato, है ना. When we go to purchase buy fruits, so at that time we say that give me 1 dozen of bananas, right? So here what does this, these all are the measuring units for our daily life. These are all the measuring units for our daily life. So ये जो measuring units हैं, we cannot say 1 kg of electron दे दो, or 1 kg of electron is present in oxygen atom, right? Or 1 kg of nitrogen is present. So ये जो 1 kg है, 1 dozen है, this measuring unit, it cannot be used for the atoms or the electrons. So there in chemistry, the measuring unit which we consider for counting the number of electrons or the atoms is your mole. So like your 1 dozen is equals to 12, like 1 kg is equals to your 1000 grams, 1 liter is equals to 1000 milliliter. Similarly 1 mole when we say, जब हम 1 mole बोलते हैं, so that is equal to 6.022 into 10 to the power 23. And this value, it is referred to be as a Avogadro's number. So it is based on the name of the scientist Avogadro. Fine. So this is the Avogadro's number, which is represented here. I have written that Na. In some books you will find it as also N0. Okay. So mole is a very simple thing. You don't need to complicate it very much. It is simply, you can see here, unit for counting atoms, molecules, ions, etc. And what is 1 mole is equal to 6.022 into 10 to the power 23 particles, which is symbolized as Na. Now in your core structure, the mole, it is in terms of mass and in terms of number. Numericals related to the moles, I'll make a different video for the practice question of this chapter, because I'm just making, I'm not explaining the whole content. This is just the rationalized syllabus as for your term 2 preparation. Okay, so just you can see this video and you can prepare yourself for your term 2 examination. So fine, let us consider the mole. As I said that in your course, so in your course, mole is being expressed into 2 types, in 2 categories: mole in terms of mass and mole in terms of number. There is one more also, mole in terms of volume, but that is not there in the NCERT, so I am not discussing into that because there is not much time with all of us to prepare for the content, right? The detailed video, if you want, then do comment in the comment section so that I can prepare a detailed video of this chapter where all the things are there in the chapter, right? Okay. So when we say mole in terms of mass and mole in terms of number, so mole can be expressed in terms of mass as well as and in terms of number as well as I said you that mole is represented by small n. Okay, how the mole is represented? It is represented by the small n. So here I'll just let you know about it. Give me a minute. Okay, atomic mass. Yeah. So in terms of mass, when you say, so it is small n is equal to small m upon capital M. Now what is this small n? This is mole. This is your mass, given mass, okay, of any object, and capital M is your molecular mass. Fine. In terms of number, if you will say, so small n is equals to capital N upon N0. These two are very important formulas. We will be seeing the questions based on this. Here it is the given any number, and this is your mole, and this is your Avogadro's number, whose value is equals to 6.022 into 10 to the power 23. Yes, so this is very important to remember this, both the formulas with respect to the mole thing. Is it clear? Now when I say 1 mole, so 1 mole, it is equal to what? As I said, it is equal to 6.022 into 10 to the power 23 particles. Suppose if I say 1 mole of hydrogen atoms, so 1 mole of hydrogen atoms is equals to 6.022 into 10 to the power that many hydrogen atoms. Okay, suppose if I'll say 1 mole of electrons, so 1 mole of electrons will be equal to what? What quantity? It will be equal to 6.022 into 10 to the power 23 electrons. Okay, based talking about this, how we are going to put this formulas into the question. So I'll make a separate video on the practice question for this set of mole concept and the other part of the laws of chemical combination. This video, just let me make it very clear that this video is just the rationalized syllabus based on the term 2. So whatever comments you feel that should be add on to this, you definitely comment in the comment section so that I'll go through and I can make the video on that. Do comment in the comment section, give your feedback about the video. Okay, so thank you.